So as part of this session, what we wanted to do was, I'm sure all of you have heard a lot about the cloud. You have heard about, how you can take your applications onto the cloud, what are the things that you can do, how do you hook onto that and stuff like that, right? But we'll spend some time in terms of considering the fact of why should I move to the cloud, what are the considerations, and should I move at all or not? Every good thing comes with some amount of bad things as well, right? And unless we are aware of what are the limitations or what are the downsides to getting onto a platform, we'll not be fully convinced in terms of why we want to use that platform for, right? So we'll spend some time in terms of coming back and looking at it in terms of, if I'm an architect, I've got a solution requirement, at what point of time and how do I go about in terms of choosing, should I consider the cloud or not, right? So that's the quick background in terms of what we'll be talking about as part of this session. One of the key reasons why we come back and start looking at the cloud as a platform is the fact that it gives us business agility. There are a lot of instances wherein a regular development kind of a cycle that we have, a regular production kind of a cycle that we have, is something that does not suit on very well. There are instances, even today, wherein we come back, design enterprise applications, large-scale applications. We do the whole architecture for it. We put down the whole design on paper. We develop the whole stuff. But we don't even have the ability to come back and test it. So there are instances wherein we have come back and done a network management software and told the customer that if you're looking at it in terms of scaling up from 1 terabyte up to say 40 terabytes of space in terms of data collection, and you want to audit it for 3 years or so, it's something that should scale up, and we have architected it for that. But we don't even have an ability to come back and even test for scenarios like that. So there are multiple instances wherein today's infrastructure really does not scale up. Today's infrastructure really does not make the cut in terms of what we want to come back and start doing. Few scenarios in terms of when we want to come back and start looking at a different kind of a platform. One, an example wherein a UK-based magazine wanted to come back and digitize its entire stuff. So they wanted to come back and say, we have got this whole magazine. We wanted to come back and scan the whole magazine. And as part of scanning this whole stuff, we wanted to come back and enable it to move online, wherein it's indexed, searchable, people can come back, look on the web, come back and query for stuff and look up details based on subscriptions, based on payment models, etc., etc. They spent some time in terms of coming back and looking at a component which came back and looked at digitized magazines, and it came back and indexed that whole stuff. So it was a proprietary component written by some Czechoslovakian company. It was the best of the lot in terms of what could come back and look at a digitization of a magazine kind of a stuff. Not only did it come back and look at all the text, but it also could come back and harvest the images. So it could come back and say, this image contains this kind of a pattern, and it typically maps onto this information that you're looking for, etc. So it was really good from a component kind of a perspective, wherein they could take all their digital assets, run it through that indexing kind of a mechanism, and come back and say, you know what, as a magazine company, we have now moved completely online, and there's a lot of things that you can come back and start doing. Once they took the whole process, did the UAT, did the initial testing, did all the work in terms of the clarity of the component, in terms of indexing, searching, wherein even though the component was perfect in terms of what it was doing, it just didn't match on to the kind of scale that they wanted. So in this instance, they turned around to the cloud, and they came back and said, I want to have a business agility. I want to come back and change the business model that we are working with. I want to go completely digital. And what they did was, they went to Amazon.com, rented out the entire space. They took on roughly around 12,000 servers, took it on for a period of 1.5 years, digitized the whole stuff, took the whole data out, and got out. So what would have taken an extremely large amount of time to come back and digitize was something they could move on to the cloud, digitize the whole aspect, take their entire multi-terabytes of data, walk away with it, and say, from now on, every month's data, it will take around 20 days for me to come back and index, which is not such a big deal, which is not such a big pain. So there are certain scenarios wherein our current infrastructure is something that just does not make the cut at all. And there are a lot of business scenarios that we let go of today when we want to come back and start working with as part of designing really large scale kind of an application. How does the whole problem of business agility start? Typically, when we come back and start building applications, we come back and say, what are the requirements? Let's take a quick hang of number of users, what is the volume of data, what is the kind of sizing that we want to do. So if you go back, talk to Microsoft as part of their database solutions, talk to Oracle, talk to any kind of a data store solution, we typically go through a data sizing kind of an exercise at the beginning of a project or at the middle of a project, wherein we get a hold over what are the kind of production systems that we need. Question there, are businesses always able to tell you that? Probably not. So if you look at a business like Twitter, if you look at a business like Google, if you look at a business like Bing or Live Services, we have no clue of the number of users that are going to come back and start hitting us. We have no clue of the number of transactions that are going to be performed. We have no clue of the volume of data that we want to come back and start holding as part of our entire data store. So in a lot of instances, questions of scale, questions of availability, questions of performance, questions of what are the kind of number of transactions, number of concurrent users, etc., becomes mute and becomes something that the customer cannot even answer to you. One of the vendors here, one of the customers here in India wanted to come back and start creating photo management applications for IPL. So essentially what they wanted to do was they wanted to say, I've got photographers, I want all the photographers to come back and take photographs as part of IPL and upload it. And as part of that, we will watermark that whole stuff and come back and put up a portal wherein people can come back and start subscribing to the photographs. So you could have consumers coming back and subscribing to Delhi Daredevils, Chennai Super Kings, etc., etc. But you also had consumers, businesses, which would come back and say, I want photographs of Sachin Tendulkar. I want photographs of some other player because he's part of my relationship. I want photographs of a certain type of a game. I want photographs with a certain kind of resolution. So businesses could also come back and start harvesting in terms of the kind of photographs that they wanted to use. When they started off, as part of designing this application, some of the questions that they were asked was, what are the kind of performance that you expect? What is the turnaround time? If somebody clicks on an image, how long should it take before the images down to the client? They were asked questions like, how many users do you think will log on at a given point in time? Now, the problem is, we have no clue. So in a lot of instances, we need to put up a business wherein we would want to grow from 0 to n without knowing what n is. And that kind of a business agility, wherein we want to really, really move fast, is something that comes with a bunch of repercussions. Right? There are scenarios like this which are not very practical today. And this kind of a business agility is what we come back and start looking at the cloud computing for. So when we come back and start saying we want to look at a cloud infrastructure, we are getting some advantages at the cost of some other benefits. We get business agility. We come back and get the benefit of coming back and saying there are new opportunities, there are newer options, there are scale, infinite scale that we can come back and look at. You've seen demos in the morning. Johnny showed some demos. Then you could come back and say, I'll put up my jukebox on the web and share it out with the rest of the people, etc., etc. Given all this kind of a background, where are we? What are the kind of applications that we have? And why are we looking at moving everything onto the cloud? We started off some time ago in terms of coming back and talking of service transformation. Service orientation, service-oriented architectures, etc. was all the big buzzwords some time ago. And we came back and said, as part of this kind of infrastructure, we first started off putting what we called as a SaaS delivery model. What's a SaaS delivery model? We came back and said, I have a hospital management system. It works for one hospital, great. The moment you design an application for a hospital management system, you could come back and ask questions like, how many beds do you have? How many doctors? How many patients? How many patients would visit? How many outpatients would you have? What are the kind of medical supplies? What is the size of your inventory? And we would get some kind of a hang of it. Now, we came out with this brilliant concept of saying, now that we've built a complete hospital management system, why don't we just put it up there, make it a subscribable, and let all the other hospitals come back and start using it. So it makes it very easy for me, new business model, new ways of making money, and literally at no additional cost. So we started building applications which we took up and started putting onto a SaaS kind of a model, software as a service or hosted kind of a model. And we came back and said, rent the software out and start using. Initially, we thought that people will not put sensitive data, but we were pleasantly surprised to come back and start seeing that people even started using QuickBooks accounting online. So they would actually take their whole corporate accounting data, put it up online as part of the cloud, and say, that's good enough for me, right? So a lot of information started moving up onto the cloud. Now, take a look at this scenario. When I'm building an application for a hospital, I can ask questions for which I can expect answers in terms of scalability, volume of data, number of transactions, etc. The moment I switch this around and say, I want to provide this as a model for multiple hospitals, now I have no clue of number of users, number of transactions, volume of data. I don't know whether we are going to have hospitals with 1,000 beds, hospital with 100 beds, hospital with 10 beds, or hospitals with 1 bed even, right? The whole question of what kind of volume do you want to support, what is the size of data, what is the number of users, etc., became completely mute. Now, this is just an example. If you had something like a security model, I could come back and say, what are the roles, doctors, patients, nurses, etc. for one hospital, and I could put a security model around it. But the moment I'm providing a SaaS model, I can't ask anybody. I need to come back and define a security model and tell them this is it. So in many instances, I need to come back and start looking at my services much before even knowing what my consumers are and what is the target market. So it is essentially, I need to come back and build the whole stuff up front as part of my SaaS model, and then take it out to people in the hope that it will click and it will satisfy the requirements. From the SaaS model, we started moving on to what we call as SOA composition. What's a SOA composition? We came back and said, instead of we giving you all the services, instead of one vendor or one provider giving you all the services, you know what? We'll integrate the services. So not only will we come back and give you a hospital management system, but we'll talk to somebody else and give you a complete patient medical records management system. We'll talk to somebody else and give you a complete billing solution. We'll talk to somebody else and give you a complete insurance solution. Because everything started moving on to a SaaS or a hosted kind of a model, you could come back and start composing services. So we came back and said, you know what, we'll put everything together. So you have a travel agency talking to a banking agency, talking to a hotel portal which comes back and books hotels, talking to some other portal which comes back and says, I'll give you discount, etc., etc. And we started merging all of these services together. Once we started merging all of these services together, we started adding on what we call as Web 2.0 features. Quick summary of my perspective of what Web 2.0 is. It is a situation or a structure wherein end users can come back and update information. Initial Web 1.0 experience was the fact that somebody put out the data and they gave it to you. In Web 2.0, you actually came back and started commenting about it. So blogging, information, coming back and putting a note which says, this hotel is not very good, that airline is not very good, this service is not very good, or this hospital services is not very good, etc., is all the extensions that we came back and started doing. So suddenly the web became a place wherein, one, we started taking all our applications, intranet, bug management system, project development systems, code hosting solutions. We started taking all of this and started putting it out on the web. Second, we took all of these and said, let's start integrating things together, and started mashing up and integrating all the things, various different services together. And third, we came back and said, once we have done this, let's get end users to come back and start updating the whole information, right? So the whole volume of data is something that started growing enormously. Once we started going down this whole direction, the dynamics in terms of how we build an application is something that changes drastically. So if you come back and look at codeplex.com, if you come back and look at any other place which comes back and hosts code, it's really difficult to come back and plan in terms of how much code I want to support. It becomes really difficult to come back and plan what kind of versions of code that I want to support. It becomes really difficult to come back and plan in terms of what geographies, what are the regulations, what is the kind of copyright information that I want to come back and start putting. Right? So all these questions becomes all the more prominent when we come back and start moving onto a service kind of an orientation. So as part of this, we need to take a look at it in multiple perspectives. One, what is the end user experience? Is it web based? Is it mobile based? Is it TV based? Is it desktop based, etc., etc.? How do we come back and monetize all of this whole stuff? In fact, one of the easiest ways to solve the problem of monetization was to come back and move to open source kind of a logic. Come back and say, irrespective of countries, irrespective of geographies, irrespective of who you are, small one guy development shop or an enterprise which is doing a large scale work, you know what, we'll just open source out everything. Right? So rather than coming back and saying no money, it initially came back and solved the problem of trying to even think about it. So that broke down the barrier for us to come back and jump onto this kind of a bandwagon. Next is, how do we come back and deliver this? What happens if I don't have access to the net? What happens if I don't have access to this whole source code? How critical is it? What is it that I should be coming back and doing? How do we come back and start composing? Somebody had asked a question in Jani's session, I think, saying if you start putting things onto the cloud, how do I do a single sign-on? How do I come back and map my security? How do I come back and map my authentication and federation as part of that whole stuff? Right? And lastly, how do I come back and do all my federated information? How do I come back and start scaling out and compose all of these in terms of large data storages? So all of these became new questions that we come back and start asking as part of putting up things as part of a hosted kind of a solution. Now, quick thought process. Most of us have been exposed to some information about the cloud. Most of us have been living with some kind of a service orientation architecture for quite some time now. Right? Let's take a quick look at what do we mean by working with services. When we are working with services, there are some key rules, thought processes, or principles when we come back and start talking about them. At a high level, I can put down 4 of them. Essentially, they come back and tell us that service boundaries are explicit. If I'm talking across 2 services, the boundaries should be very explicit and clear. Services are autonomous. They work completely independent of each other. Services share schema and contract, not type. And services are compatible based on policy. Just text, not something that makes too much of sense to us. So let's take an example. Let's take an example of a large corporation which comes back and says something like Infosys, Wipro, etc. It's a decently large corporation. Now they come back and say, as part of my organization setup, I have 2 options. If I want to manage my travel desk, I can either hire a guy who is internal and manages my travel desk for me, or I can outsource my entire travel desk requirements out to a third-party agency. What is the primary and the fundamental differences across both of these models? In one model, when you want to hire somebody, you come back and put out a requirement which says, I want a travel desk guy and I want to hire the whole person. You can put out some kind of a job description. It's fair for that person to come back and ask you, how much of travel do you do? Am I expected to stay late in the night? What is the kind of work that I'll have? Will I have off days? What is the whole plan for that? How do I identify that somebody is an employee? What are the kind of bookings that I'm expected to do? He can come back, ask a lot of questions and expect to get answers. If, however, instead of hiring that whole guy on, we come back and say there is a third-party travel agency and we want to outsource to that travel agency. And I want to come back and set up a travel agency. Can I ask those questions now? Can I ask a question in terms of how many bookings do you want to need? What is the kind of bookings that you want me to do? Do you want me to do rail bookings or airline bookings or some other bookings? What are the kind of security policy that you have? Are these questions I can now come back and start asking if I'm setting up a travel agency? I can't. So there's a fundamental difference between us hiring somebody to take care of my travel desk versus outsourcing the entire work to a travel agency. Why do we come back and outsource the entire work to a third-party travel agency kind of a stuff? Because it gives us business agility. It gives us the benefit of saying, I can move from one person to another. I can scale out my operation. I can do 1 ticket booking today, I can do 1,000 tomorrow. I can do 10,000 day after tomorrow. The problem of scale is not mine any longer. It's something I've given it off to somebody else. So it makes it very easy to come back and say, I actually want to start coming back and consuming services rather than holding on internal definitions, rather than hiring a person who can come back and do my travel desk, rather than hiring a person who can come back and do security, rather than hiring a person who can come back and manage administration. it makes so much more sense for me to come back and say, you know what, we'll just outsource all of these. Moving to the cloud is a very similar experience. So today when we want to move to the cloud, what we come back and say is, it's agile, it scales, it does a lot of work, you know what, let's just outsource it out there. But you know what, it doesn't solve the problems. A lot of instances, the day you want to come back and say, I want to work with a travel agency for doing all the booking, and you go and talk to a travel agency and say, you know what, I want to tie my company up with yours, the first question they come back and ask you is, what is the kind of services that you need, what is the contract, and what do you want out of this? Do you want a response time in 2 days? Do you want a response time in 3 days? How do you want me to do all my billing? Do you want me to do a billing on a regular basis, on a per transaction basis? Do you want me to do a billing at the end of the whole schema? How do I come back and authenticate your people? You need to give me some kind of a logic which says somebody will approve the whole stuff, give it to me, and only then I will process it. So the moment you come back and outsource your work somewhere else, you suddenly need a lot of new processes, which comes back and defines the whole stuff. When the person was internal, he would come back and say, tell me your employee ID, I'll come back, do the whole booking for you, I'll run it through your manager, as long as he approves, I'm fine. But a travel agency does not have that luxury. It does not even know who you are. So me giving my employee ID has no bearing whatsoever to him. Right? So in his case, he comes back and says, I need it to come from a specific source. I need somebody authorized. I need that person to take ownership of everything that's being sent to me. I have an internal travel desk guy. I want something in the evening at 6:30. I want a ticket to be booked in the evening at 6:30. I come back and say, you know, I need this done urgently. If he doesn't perform well, I talk to my manager, who talks to his manager, who gets him to stay back late and do the whole work. Right? The moment the whole work is outsourced, I come back and say, I want a ticket booking done. They'll say, sorry sir, we are closed for the day, please come back tomorrow. So in many senses, the moment we come back and outsource, the moment we come back and give responsibility out to somebody else, there's a lot of new processes that we had never thought of which comes into play. Now, keeping this in the background, take a look at these definitions. In the instance that we want to come back and outsource the entire work to somebody else, the service boundaries are very explicit. It comes back and says, our services are provided based on contract, not based on what we can do. The boundaries are very explicit. You can't just walk in and say, I want something done immediately. There is a certain process, and everything goes through a very formal process in terms of what you can do. Services are autonomous. I can't ask my boss to shout at his boss and get the whole work done. I can't take shortcuts. I can't break rules. I can't impersonate somebody else and come back and get the whole work done. Right? I can't sign for somebody else and come back and get the whole work done. The services are completely autonomous. When the travel desk guy comes to my office, his security model is exactly the same as mine. He goes through the same security check. He has got an employee ID. I've got an employee ID. It's exactly the same security model. The moment I outsource the work, his security model is completely different from mine. How do we identify that person? There is no clue. There is a telephone number, there is an email ID, you send the mail, you'll get the response. But you have no clue who that person actually is. So you lose track of instances of that code, instances of that component. All you know is there's an interface and you have to walk through that interface for you to get to it. Services share schema and contract, not type, and they are based on policy. So for example, if you've got a search API which comes back and says, free service, we will respond to you in 3 to 10 seconds. Paid service will respond to you in 0.5 seconds. Look at it. The fact that they can do in 0.5 seconds means they have the ability to do it, but you don't get it. The fact that if you outsource to an external agency, he can book train tickets, he can book bus, he can book cab is different. If it's not part of the contract, he does not book it. If the guy is sitting internally, you tell him whatever he can do and he probably does all of that. So given this kind of a background, take a look at it in terms of what we do. Today, what we do is we come back and say, I want to use a third-party service. I want to use a login service. I want to use an authentication service. Or even for that matter, I want to use an Amazon or an Azure storage service. It gives you the capability of storage, size, space. And we come back and say, wow, that's great, and we start using it. we don't come back and look at it in terms of how secure is the data. We don't come back and look at it in terms of what is the performance. When Johnny was doing the whole sample, he typed out the URL and it took quite some time to come out. Right? It could be due to various reasons. But who guarantees service? Who guarantees performance? Who guarantees a turnaround time for this whole stuff? All of that is something that is not very clearly defined. So the moment we come back and say, I want to use some service, I want to use an Azure service, I want to use an Amazon service, I want to use .NET services, live services, Google services, etc. Some of the things that we have to be very careful about is the fact that we have to be very clear from a contractual perspective of what to expect and what not to expect. As part of this kind of a service orientation, key definition is the fact that whenever we work with services, typically services have a set of structures. They are self-configuring. What do we mean by self-configuring? They work by themselves. If there is a definition which says, I want to scale, I want to add on, I want to upgrade myself, there is a new version that is out there, there is a new capability out there, etc., it upgrades itself. I don't have to be bothered about it. I don't have to worry about it. It does not break my existing contracts. So if I have a bunch of APIs out there which come back and work with Bing search, I have a bunch of APIs out there which come back and work with Google search, they will not break when Google comes back and starts upgrading this stuff. However, there is a contract. So when we come back and sign up to come back and say we will use these APIs, we are given a contract which says this contract will last for X period of time. This contract will last till this date. After that, you need to come back and automatically upgrade and do some work behind it. So the benefit that you get is based on the contract that is defined and not based on anything else. It is self-adapting. If it now wants to come back and say, I had 10 users, I had 100 users, I have 1,000 users, I have X number of users, it adapts itself. I don't have to be bothered about it. Right? It will come back and scale. It will come back and work with the whole structure. It will come back and figure out what it wants to do. It is self-healing. In case there is a bug, in case there is an error, in case there is a log, in case there is an audit requirement, etc., it is its problem, not mine. Right? It will do all of that stuff. If I come back and have an agreement which says, I will get the report of my Azure bandwidth usage on a regular monthly kind of a basis, I will get that report. If I come back and say I want a daily report, I want an hourly report, I want a per transaction report, if it's part of my contract, I'll get it. If it's not part of my contract, I'll not get it. But assuming that somebody might want it, they need to build in these capabilities anyways. Right? So the capability that is getting built as part of the server is something that is not dependent on the contracts that are being given out. It is self-optimizing. It optimizes itself. New policies come in, new structures come in, cheaper bandwidth comes in, cheaper hardware comes in. They come back and self-optimize, and if they so decide, they pass on these benefits down to us as consumers of these services. And they are what we call as self-protecting. There's a problem, there's an error, they figure out what to do. They can cut out the service, come back and say, we are sorry, but they protect themselves in terms of what they want to do. So the moment we come back and start saying we want to leverage a bunch of features of the cloud, we want to leverage a bunch of features in terms of services that are being given by somebody else, we have to be very clear of what we expect from that service. Now, there are two perspectives. I, as a user, can come back and say, I want to consume these services, or I can come back and say, I, as a developer, I want to come back and provide these services. It's actually two completely different perspectives. If I'm consuming services, my life is very easy. I just have to look out for services that help me. Oh, there's storage service? Great, I'll use it. Some of the service that's there? Great, I'll use it. I just need to ask the right questions. I need to come back and say, will my storage service give me encryption? Does it? Doesn't it? Will my storage give me space? Automatically increasing kind of a space. Will my storage service come back and give me compression, or come back and give me some other logistics in terms of what I want? So I come back, ask the questions in terms of what I want from my contract, and based on that, look at the whole stuff and come back and start consuming it. Consuming services is very good. Consuming services is very easy and something that we can get started off quite soon. The problem is on the other side. What happens when you want to come back and start providing services? So most of the demos applications that we looked at is, how do you take your code? How do you take your .NET code? How do you take your Java code? How do you take your PHP, Python code, etc.? Put it out on the cloud and start giving out services to people. A lot of us, Microsoft, non-Microsoft, Amazon, etc., will come back and promise you in terms of saying, even Google Apps to some extent comes back and promises you saying, take your application, minimal changes, put it up as part of the cloud, and it's something that you can come back and start working with. We see one aspect of it, which is the elasticity. We can just add more servers, add more processors, and it sounds very happy. Questions that we need to ask is, what about data protection? What about security? What about performance? If, for example, I'm depending on a Windows Live authentication for me to log into my system, if authentication takes over 6 to 7 minutes, how can I guarantee a performance to my customers? If a search engine comes back and gives me a performance of anywhere between 10 to 40 seconds, how can I guarantee less than 2-second response times to my customers? So the moment we come back and start working with these kind of services, we have to be very explicit of what we want and what we don't want. So quick question, if we come back and start using cloud-based services, do we get a benefit as part of cost? Is it a cost advantageous to us or not? Assuming we want to scale, assuming there is a large scale deployment, we don't know number of users, we could scale from 1,000 users up to 1,000,000 users kind of a stuff. Is it a better cost advantage of moving to the cloud or not? Yes? May or may not be, right? It depends on the contract. So as an example, when large companies, say an Infosys comes back and says, we want to outsource our security, it has two perspectives to it. Perspective one, I want to come back and save on cost. Rather than me having all the people, outsource it to a security agency, have 3-4 different security agencies, get the best bid, cut down the price, and get a better cost as part of that whole structure. But on the other side, it also wants to come back and say, you know what, if there's a new threat, I would rather my security agency be beefed up to handle it. I don't mind paying a premium, provided I get the capabilities that I want. I don't mind paying a premium, provided I can be guaranteed that security works properly. So as part of this kind of infrastructure, when we come back and start talking of service features, if you notice, as part of all of this stuff, even though we have come back and said self-optimizing, cost benefit is not always a given. As part of sales, Microsoft, Amazon, etc., everyone will come back and tell you there is a cost benefit, but it is not inherent. It is not guaranteed. It is not assumed. There is a city called Lavasa between Mumbai-Pune highway. The whole city has made a choice in terms of coming back and saying we want our infrastructure to be off the cloud, and they are now been running off the cloud for over 6 months, and they're looking in terms of continuing that way itself going forward. The director of the company, when they came back and he presented a cloud conference, he came back and said, our cost benefits are negligible. When we did an analysis, the kind of cost that we had before is very similar to the kind of cost that we have now. The benefit that we have is, before I had to worry about 200 different servers, different applications and stuff like that. Now I had to worry about network connectivity. That's it. All the rest is off the cloud. All the rest is easily commissionable. So the kind of problems that you have changes, the kind of maintenance that you have to do, the kind of things that you have to take care of changes, and you don't necessarily always get a cost kind of a benefit. When you come back and see a cost benefit, when you have low level definitions, you have a definition which says, I want to save on space, I want to save on infrastructure, I want to save on computing power, I want to save on just hard disk space, then you might get a cost benefit. But when you come back and tack on questions like security, like scalability, like performance, response times, etc., bandwidth usage, bandwidth consumption, etc., it becomes ambiguous. The whole Azure billing, if you come back and take a look at it, Amazon billing, Azure billing, etc., it's very similar to our cell phone bills today. So Airtel, Vodafone, all of them come back and tell you, night 9:30 to 11:30, it is discounted at 50%. How many of us actually come back, make a call at 9:20, continue it all the way up to 9:40, and figure out whether half the conversation we got 0.5% discount or not? Right? We rarely do that. There are a few of us who are good at it, okay? But most of us take a look at the bill, pay. As long as it is not too bad. If it was 800 rupees last time, this time it was around 1000 rupees, we are fine. If it's 2000 rupees, we'll go and ask them a question. Right? So the only thing that we actually do from a billing kind of a perspective is look at exceptions. A few questions that you need to be bothered about, even for very simple scenarios. Amazon, Azure, etc. come back and give you space, come back and give you storage. They also give you an option to come back and store the data as compressed. Right? So they come back and say, no, I'll compress the whole drive. You can put up your data there and I'll compress it. So question, when we come back and say so much space is being utilized, is it the uncompressed files or is it the compressed files? We're not very sure. If as part of my file upload, there is a lot of metadata and logs being kept, are the logs being built to me or the logs is being built as part of the system? We're not very sure. When we come back and calculate bandwidth usage, I come back and download some data, there's an error in the connection and it comes back and re-downloads the whole data. There is a multiple bandwidth usage that comes about. What part of the bandwidth are we giving or what part of the bandwidth are we paying for? We're not very sure. Are we getting the compressed data down as part of the network or is it raw uncompressed data that's coming down as part of the network? Again, we're not very sure. Even in the simple example that Johnny did, I can put up my MP3 file out there and I can tell it compressed and I can tell it stream as compressed and I can come back and decompress on my client, which ensures that I can actually save on storage and save on bandwidth and stuff. Is that what they're taking into account? We're not very sure. So one of the things that you need to be careful about when we come back and start looking at this kind of a system is the fact that it gives us a lot of benefit in terms of what it does. It is a complete service, it is completely autonomous, and we have a lot of benefit when we come back and start consuming it. But unless we are clear from a contractual perspective of what we are getting, it's something that we will not be very sure. What do we mean by the contract? The contract is not necessarily a physical paper. It is the interfaces that we work to. Simple things like we need to come back and say, call as an Azure service. If I don't get a response time in not so much period of time, please come put an error log and get out. Don't come back and wait for infinity for me to come back and raise exception handling. Definitions of what I can get, how long I can connect, what is the downtime, etc. is something that needs to be built into the whole structure itself. With this kind of a thought process, there are multiple offerings that are out there. We have software as a service. Software as a service is the simplest of the lot. There is a software, QuickBooks, hospital management system, scheduling system, mailing systems, Gmail, etc., etc. We come back, take a definition of software as a service, subscribe to the software, and start working with it. In fact, if you notice, most of the software that we give as a service, we rarely come back and define what we call as non-functional requirement. Right? Recently, Google Gmail security model was hacked. Much before that, Microsoft Live Services was hacked. Right? Is this something that we care about? Is this something that was there as part of a contract? If you go back and take a look at the agreement that we clicked OK to when we subscribe to the service, it said basically you absolve me of everything. Right? You come back, you get a feature, that's all that you get. So the moment you come back and start using software as a service, there is no guarantee of the non-functional requirement. All you're given is a functionality that works. I will track this information, I will keep this information. That's about it. Okay? When you start moving to platform as a service, like for example, you have SharePoint as a service, or you have got some bunch of live services, or you've got search as a service, or you've got maps as a service, you now come back and have an additional layer below. You build your application on top of it. If the underlying service does not give you any guarantee, your applications that you build on top of them, you will not be able to give any guarantee. How can you come back and guarantee that your XY location or latitude, longitude location that you have defined is correctly depicted on the map? How can you ensure it's not lying in the middle of some ocean somewhere in terms of mapping on? Unless the service below comes back and gives you that kind of a guarantee, you will not be able to give it out. So software as a service, we just come back and subscribe to the software and start using. Platform as a service, we need to be much more careful because we are going to now start building functionality, logic, etc. on top of this whole stuff. And the biggest challenge that comes up is when we start looking at infrastructure as a service, right? Which is what Amazon, Azure, etc. comes back and start providing us with. So what do they essentially come back and give? They essentially come back and tell us, we will put up infinite infrastructure. We will put up a huge amount of infrastructure. All you do, come back, take it as a service, use it, and let go of it. It's very similar to when this whole auditorium was built. When the auditorium was built, we didn't come back and say, what all will this auditorium be used for? What are the kind of capacity? How many users, etc., etc. A thought was done and built. quick small note here, and this is something that we do good as part of engineering applications, and it's something that we don't do very good as part of software. When we want to come back and build something, we give a lot of buffers. If you want to build a car which can hold 5 people, we assume it can take the weight of 10 people. When we build a lift which says maximum capacity of 9 people, we build it to withstand 25 people. When we come back and start building software, that kind of a buffer is something that we don't always give. So we don't come back and say you have 1,000 concurrent users. Even if you go from 1,000 concurrent users up to 8,000 concurrent users, the system will still continue to work. That kind of a buffers is something that we don't build in. You need to start planning for these buffers. The moment you use software as a service, you need to add on buffers. The moment you use platform as a service, your buffers increases. The moment you go to infrastructure as a service, your buffers becomes even more. Right? So the moment you start looking at taking all your applications and moving it onto the cloud, remember that the amount of buffers that you have to give is something that becomes substantially huge. Right? It's something that we do in real life always. When we come back and say a bridge has to take the weight of 500 cars, we design it for 5,000 cars. We design it for 10,000 cars. Right? We don't always design it for just 500 cars. So the moment you come back and start designing for a cloud kind of a computing or a cloud-based infrastructure, you need to be careful of adding on a huge amount of buffers when you come back and start working with it. All your definitions of security, all your definitions of scalability, volume of data, etc. is something you literally need to multiply by 10 in terms of what you want to come back and start providing. Most importantly, when you start taking a look at all of this, start looking at what we call as a blended approach. It is very difficult to come back and start saying, day 0, I'll move on to the cloud. Today, the entire cloud platform is at a stage where, Oliver and Wilbur Smith had found out the aeroplane. It could fly. It was a great idea. Companies had come back and started setting up, aeroplane manufacturing units, and things could fly. But till you had the whole logistics of airports, of countries which came back and put up the whole passport regulation, etc., it did not become mainstream. So there's a lot more to flying than just an aeroplane flying around. Right? It needed a huge bunch of regulations before we could even come back and start using it. Something as simple as how do you use toilets in the air. Till you figured that out, we could not even make long distance travel practical. Right? And that is something which is not core to flying at all. So what is important when we come back and start moving to this kind of infrastructure is to come back and ask all the related questions around in terms of what we can expect and what we can't. If today we get an application, we need to come back and say, for this application, what are my requirements? If my requirement is agility, my requirement is infinite data, my infinite is huge computing power, I can get that at a cost of security, at a cost of ambiguousness, at the cost of unsure billing kind of a definitions, at a cost of speed of response time. Right? All of these is something I can come back and say, I will just throw more hardware at you. When you come back and start looking at the cloud, do you even have a clue whether you're getting 32-bit machines, 64-bit machines, 128-bit machines? We have no clue, right? We just come back and say, I will subscribe to it, and hopefully at some point of time, things will just become better. So it's very important to come back and say, what parts of my application will I start moving on to this kind of infrastructure? What is it I will keep locally? And that is where this whole definition of a continuum comes in. It makes a lot of sense to come back and say, I will have something which is core to me. As an example, if Infosys is a software development company, it comes back and says, I will outsource security, I will outsource my food, I will outsource my administration, I'll outsource coffee tea, I'll outsource cleaning. I probably will not outsource software development because that's core to me. That is a service I am providing to others. However, if you go back and talk to people at Infosys, they say, you know what, that is also something we have started outsourcing. We take software development, we take another small companies and give it out to them. In a sense, what they're doing is they're coming back and redefining the core of their business. The core of their business is essentially brand management and project management and not necessarily software delivery. How do we come back and identify services? How do we come back and identify services that can go onto the cloud? Quite easily, two perspectives. One, opportunities. I want to get an infrastructure which can't be matched. I want to get a security, infrastructures, a bunch of security people who can handle the best threats in the world. I'm willing to pay for it. It's So very similarly, I want to come back and get infinite computing power, infinite space, and a huge amount of computing resources. I'm willing to pay for it and move on to the cloud. The payment is not just onto the cloud. The payment is for all the supporting services around it. Right? How do I manage backup? How do I manage recovery? How do I manage security? How do I manage a ton of other things? That's what I'm paying for. So either I pay for opportunity, based on which I come back and start moving onto a cloud kind of infrastructure, right? Or I come back and say, you know what? I want to look at this kind of infrastructure primarily from a cost perspective. I want to come back and say, let's jump onto this whole bandwagon. Let's start doing some things internally. Whatever is not core to my system, let's come back and start hiving it off. Same example, digitization of the magazine. They could come back, rent the space for 1.5 years, do the whole computing, get out. Right? They just needed it on a temporary kind of a basis. If you want to do analysis services, you want to come back and do large amount of computing. Last 200 years of data, you want to come back and do some projections. Take the whole data, do the whole computation, use it for your projections, get out. Right? So you have the option of either moving your core services onto the cloud or moving what we call as peripheral services onto the cloud. And that's where you can come back and start looking at a bunch of platform services that are out there. I've put a bunch of examples from Microsoft Live Services, but it's pretty much true from any kind of a service. A good example of a service that is being consumed is something called scheduling services. So one of the hospitals in the US came back and said, we have a lot of scheduling to do. We have to schedule users to rooms, we have to schedule doctors to users, we have to come back and do a schedule of which doctor has to visit what room, etc., etc., etc. It had to take care of multiple geographies, it had to take care of daylight saving, it had to take care of changing rules in terms of work hours, it had to take care of the fact that a doctor was available, not available, he had his own personal schedule, he had conferences to attend, etc., etc. Right? So they came back and said, you know what, let's just subscribe to a scheduling service, and the guarantee the scheduling service will give me is that it will ensure nothing is overlapped. It gives me a guarantee from a performance perspective that things will happen in not more than a few seconds kind of a stuff. Right? So Azure is something which is similar in terms of what you can do. One additional pain point that we have got as part of this whole infrastructure service is the fact that it is a very low level service. What are the APIs that are available, what are the capabilities that are available, etc. is something that we need to question. While on the local desktop platform, on a Windows operating system, on a Linux operating system, there's a certain amount of capabilities I get. How much of that will I get when I move on to an infrastructure is a question that I need to come back and start asking. Will I get multi-threading? Will I get multiple processors? Will I get a hold over this? Can I come back and lock out threads? Can I come back and figure out what are the kind of utilization of resources, etc. are questions that we need to come back and ask. So quick summary and thought process. A lot of times we see demos which work. We see, I can write this code, put it onto the cloud. We see, oh, cloud is great. It helps me in terms of, literally infinite scalability. And we come back and say, it probably makes sense. We need to be careful of what is the business value we want out of this whole platform. We need to look at it as a service. We need to look at it as a work that we outsource to somebody else. If I come back and start managing things internally, it's a pain for me, but it's under my control. When I'm not sure of what I want, when I want somebody else to come back and improve and work upon and harvest and take the whole thing forward, that's when services starts making sense. Right? And that's the way you should come back and start looking at it when you want to come back and say, I want to use some kind of a cloud computing as part of my value. Going forward, there is a lot of business value, and the business value primarily comes out of agility. It comes out of the benefit of saying, I can change things very easily. I can come back and take terabytes, petabytes of data, and I can come back and do some operations without it. So cloud, moving on to the cloud is more in terms of using or leveraging newer opportunities and not necessarily taking what we are doing and putting it out there. If I can write a jukebox, I can probably write it anywhere. If I can write a streaming kind of a service, I can probably write it anywhere. Right? The benefit we get is when we want to come back and start leveraging newer opportunities as part of this infrastructure. Right? So key summary, services are defined by the business offering and not by the technology offering. So when you come back and start saying I want to move to the cloud, you need to have what is your business plan behind it and not the fact that I can write some code and put it there. Right? You need to come back and ask the questions of saying, is this data important for my business? Is encryption important? Is security important? Is performance critical? If from 2 seconds it takes 20 seconds, will it kill my entire business model or will it not? Or can I come back and say, if you want better response time, pay me more money? Can I make an opportunity out of it in terms of monetizing that whole stuff? So your whole thought process of moving onto the cloud is something that is more closer to the business model rather than to the technology infrastructure that's available to us today. Right? So that is a quick summary and a thought process in terms of what we should look at when we want to come back and start moving to a cloud kind of a platform. Okay, so apparently I can take one question if there are any. Okay, and after that we'll be taking all the rest offline. None? Yes.
Of the entire cloud.
Right. So his question is, what happens if I have a bunch of customers and all the customers want to scale up at the same point in time, same spurt happens and all of them want to scale up at the same instance of time. It's very similar to saying, I'm a travel agency and I'm servicing Wipro, Infosys, 10 other companies, and all of them come back with a travel booking at the same instance of time, right? And they sit on their butt, for the last 10 months and suddenly decide one fine day that all of them want to travel. I will come back and start having inconsistencies. I will come back and start having problems. I will not probably be able to service all of them. And what I do is I start losing revenue, right? None of them own it. So the difference is, if I am an Infosys and I own the structure, I know what I can get out of it. But if I'm not an Infosys, if I outsource this whole work to somebody else, I don't know what I can get out of it. I can hold them to their contract, saying, this is a contract that we had more than so much period of time, you are taking more than this, you're not servicing this request. I can come back and say, no, there is a default and so we won't pay kind of a stuff. But other than that, there's not much that you can do. That is true, for example, if you come back and say, I will give you some data, and if the data gets leaked out, who is responsible for it? Similar kind of a consideration. One last point to sort of add on to that is, one of the things that people are not very clear is, where does the cloud jurisdiction lie? So recently there was this instance wherein US government came back and told Google that I want to access so many mail accounts because there are some terrorist threats. Now, people from all over the world have subscribed to Google services, but it happens to lie in the jurisdiction of the USA, in the state of California, right? Now, I'm not very sure if I come back and start uploading data into the cloud and the cloud servers are of some Mozambique queue somewhere, I'm not sure it falls under what jurisdiction. So one part is, there will be defaults of service. Second is, if there is a default of service, who do I go to? Is something that's totally ambiguous, right? So those are issues that we'll have to sort of deal with when we come back to the cloud. Like I said, as part of the cloud computing platform, we are in a stage wherein we have built the aeroplanes. We still need to figure out the passport policy, how to build the airport, where to put in the security, where to put the security checks, etc., before we actually come back and start taking off. And remember, that is a huge pain from a policy definition and implementation, and got nothing to do with just the technology part of it.